Let's now look at case 2 of integrals involving powers of sine and cosine. Case 2 is when the cosine power is odd, such as the 3 in this example. I've written down the steps that we can follow, and we'll walk through these as we walk through our example. We're going to integrate cosine cubed x dx. Our first step, written right up here, is to pull off 1 cosine x and group it with dx. Let's go ahead and let's do that. This gives us the integral cosine squared x. That's what's left when we pull off 1 cosine x. And then we're going to group our cosine x with our dx. The reason that we did this is we can now write our cosine squared x in terms of sine squared, and then this cosine x dx is our derivative. Let's look at step 2. I kind of just went over this. We are going to rewrite cosine squared in terms of sine squared. So our cosine squared x is 1 minus sine squared x. I put that identity up on the right so that you'll have it. And then we have our cosine x dx. Now let's look at step 3. We are going to let u be equal to sine x, and we're going to integrate using u-substitution. We'll let u be sine x, and then we'll rewrite our integral. This gives us the integral 1 minus u squared, and then our du is cosine x dx. So we'll just multiply this by du. Now we can go ahead and integrate it. The integral of 1 is going to be u, and then we have minus u cubed over 3 plus our arbitrary constant. And then the last thing we have to do is to just look back up here and see what we put in for u. We put that u is sine x, so this gives us the answer sine x minus, I'm going to pull that 3 out in front, so minus 1/3 sine cubed x plus c. And there's our answer.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.